Hello, my name is Cameron Swin, and I'm the Strategic Marketing Manager for Industrial Control and Automation in the Embedded Group at AMD. Today I want to talk to you about a couple of popular trends in industrial control and automation applications. There are many existing and developing trends in industrial control and automation applications that OEMs and manufacturers alike need to be concerned with. 9 of these trends are efficiency, sustainability, connectivity, security, usability, safety, integration, scalability, and reliability. Automation has enabled factories to operate more efficiently by enabling fewer workers to generate more output. There are less than two-thirds the number of U.S. factory workers today than there were in 1998, but each produces over twice the output than they did then. To stay competitive, systems must increase their output while requiring less operator interaction. The latest generation of high-tech industrial control and automation systems are delivering excellent usability and performance to enable plant operators to push the process, operation, and equipment to its design limits. Sustainability is a complex trend with a variety of influences. According to the International Energy Agency, industrial energy consumption constitutes 30% of global energy use and is projected to increase at a rapid rate. So industry is consuming a lot of energy, and the high energy prices we are experiencing is hitting manufacturers' bottom line. At the same time, worldwide initiatives to reduce CO2 emissions are squeezing manufacturers to reduce their consumption of energy. For example, the International Energy Agency is driving to halve global emissions from 2005 levels by 2050. The combination of these factors is driving manufacturers to reduce their energy usage. To reduce power, systems must not only operate efficiently, but they must be intelligent enough to help the rest of the system to operate efficiently, such as intelligently controlling the torque profile of motors to efficiently spin up to speed, or using variable frequency drives to control motor speeds. Or in industrial process heating, improvements to process control can help reduce energy consumption by keeping the process running at capacity to minimize storage losses related to cycling a process heating system from off to on. Reducing power in a manufacturing facility involves 4 steps: measuring, visualization, management, and finally reduction. So by delivering more intelligence deeper into the factory floor to continually and automatically monitor, analyze, and report the power consumption of a system, intelligent controllers can help identify problems and make adjustments to help reduce the energy used by a factory. The Internet of Things is driving towards billions of devices being connected by 2020. According to IMS research, this started with the first wave of computers and laptops, followed by a second wave of smartphones and connected consumer devices. The third wave includes those devices but substantially increases with the connection of machines to other machines. This ties into things like plant integration, where everything is being connected and a lot of data is being generated. Vendors are investigating ways to turn that data into actionable information. Systems must be able to manage all of the data and be smart enough to independently, or with minimal operator interaction, act on the data to increase factory efficiency. And a new concept developed by German experts called Industry 4.0 refers to the fourth industrial revolution, which looks at the connected factory and what it is evolving into. The integration of product development, logistics, and manufacturing will be enabled through the flow of materials, products, and information to create highly complex and efficient worldwide manufacturing operations. Where a manufacturing line can be tied into both the supplier and consumption information to dynamically adjust what is being manufactured based on consumer demand and accordingly adjust the raw materials being delivered. Technology is helping to enable advanced control systems on the factory floor to efficiently communicate with one another to manage and analyze the data that is being gathered, and communicate to distributed control systems and enterprise IT networks. This helps to enable plant operators to track and identify areas to reduce idle or downtime, improve efficiency, and coordinate production capacity with demand. In industrial applications, security is becoming less of an afterthought and in some cases a main consideration at the beginning of product and system design. Typical IT security methods are not effective as industrial applications have different priorities. IT security applications generally focus on confidentiality and integrity of data and require high throughput on servers where high processing capability is readily available. In industrial applications, the focus is on human safety and fault tolerance and requires high availability and low latency. All of this on systems that often have limited processing capability available. New security solutions are being developed that are going to benefit both mobile and industrial applications, where limited processing performance is available. For example, in 2012, AMD announced a collaboration to extend ARM Trust Zone security technology into x86-based AMD solutions. This will leverage a proven industry security technology into what we call a platform security processor, which will be an integrated coprocessor next to the AMD processor cores. By integrating a hardware security engine into a processor, low-power devices will be able to leverage advanced security capabilities while keeping the system power low and without consuming valuable processing resources. Usability of industrial applications has helped improve the efficiency of factories in the last decade. By enabling users to act on more information quicker and more accurately and facilitate maintenance and troubleshooting. To make these interfaces more intuitive, operator panel OEMs are beginning to implement consumer-like interfaces with gesture-based inputs like those users have already become familiar with on smart devices and gaming consoles. And the potential of analytics, 3D graphics, and video to further increase operator efficiency is only just now being tapped into. But for factories and their operators to fully benefit from the usability afforded by these advanced technologies, they must be consistently implemented in all of the HMI devices across the factory. The scalability of processing solutions that are now available can deliver excellent graphics performance and a consistent user experience in both low-power solutions targeted at smaller mobile operator panels and high-performance solutions needed for large or integrated operator panels. This chart shows that the output per U.S. worker has doubled since 1998, while at the same time injuries and fatalities in the manufacturing workplace have declined more than 50%. Indicating an increase in factory safety. Certainly, industrial safety standards such as ISO 13849 and others have and are continuing to contribute to this decline, but safety regulations can make system designs more complex. Increases in intelligence deeper into the factory floor is enabling systems to be instrumented to detect dangerous conditions or abnormal operation without impacting the speed of production. So while automation has increased a worker's productivity, it has also made it a safer environment to work in. New software, technologies, and products related to incorporating intelligence deeper into the factory floor are on the rise to help OEMs who need to implement functional safety into their equipment. Some of the reasons to integrate functions on the factory floor include to reduce system cost, power, installation and maintenance costs, easier integration and deployment, reduced user training time, as well as increased security and reliability. In industrial applications, we are seeing operator panels being integrated with industrial PCs or PLCs. While these two solutions can be based on similar processing architectures, they have very different requirements for the software that runs on them. Operator panels predominantly utilize Windows operating systems to develop their user interface, and industrial PCs or PLCs utilize real-time operating systems to ensure reliable and responsive operation. To effectively integrate these two solutions, the integrated system must perform the functions of each just as well, or better, than the individual platforms. The key to achieving this usage scenario is to leverage virtualization technology to enable processors to run multiple independent and isolated operating systems on a single platform. So, for example, Windows could be utilized to develop a full-featured and immersive graphical user interface, and a real-time operating system can be implemented to perform time and safety-critical functions all on the same processor. We are also seeing the use of virtualization to improve security in industrial communications, where a single platform can communicate with the cloud or smart devices through an unsecured domain and perform real-time or safety-critical control operations in a separate, secure, and trusted domain on the same platform. Hardware and software development are a big expense in both time and money for industrial OEMs, and like everyone, OEMs are working to reduce those development costs. One way of achieving reduced development costs is to leverage the same processor architecture across their product line. By leveraging the same processor architecture, they are able to reuse software in multiple products ranging from machine vision cameras or PLCs on up to high-performance operator panels and servers in distributed control systems. And leveraging the same architecture can also simplify hardware development, enabling reuse of design materials in multiple products and maybe even leverage the same board design in different categories of products. With each new generation of processor, we see the price, power, and performance scalability increase. ARM-based solutions are increasing their performance and now are able to meet the performance needs of server-class applications, while at the same time, x86 processors driving down their power consumption to serve compact low-power designs. This is enabling OEMs to utilize one architecture and platform to serve a wide range of products, while at the same time meeting the performance requirements and fitting within the power and cost constraints of each specific product. Reliability is essential in manufacturing and process control applications where a single breakdown can have an impact on the profitability of operations. And reliability must be accounted for both at design time as well as in maintenance process improvements. In board and system designs, the trend toward leveraging commercial off-the-shelf solutions or standardized components means that replacement parts can be readily available. The goal to reduce power for sustainability and cost reasons is reducing thermal stresses on the rest of the components in the system, helping make them more reliable. Leveraging standardized architectures can help reduce complexity and simplify system design, reducing the likelihood of design mistakes and latent bugs or failures. The latest generation of processing solutions with support for error-correcting memory and extended temperatures also support virtualization to help isolate the critical from the non-critical functions to ensure reliable operation. And support for remote management can enable proactive maintenance and software updates to keep machines running reliably. AMD's x86-based solutions deliver good performance to help plant operators to efficiently monitor and control the factory, to push the process, operation, and equipment to their design limits, and improve factory efficiency. For sustainability, where the goal is to reduce energy costs and emissions, the excellent performance per watt and remote management capabilities of the AMD solutions help individual systems conserve energy both while operating and while idle. And through their data throughput, management, and visualization capabilities, AMD-based solutions enable real-time measurement of power-related data and the high-quality visualization of that data to support the analysis and management of systems to help other factory systems to operate near capacity and operate more efficiently. With the coming age of the Internet of Things, where we are going to see billions of connected devices, the data management capabilities of the x86 architecture can help enable devices to easily capture and act on large amounts of data. And the compatibility of AMD solutions with enterprise IT systems enable the same software applications to be run in systems on the factory floor that are being run on IT management or distributed control systems, enabling them to store and share data with manufacturing ERP systems, increasing the overall connectivity of the operation. With the growing awareness and concern over security threats, the development and integration of hardware security engines into low-power processing solutions will enable them to meet the processing needs of real-time process control applications without worrying about the processing overhead of security functions. Leveraging an open industry standard ecosystem of security solutions, OEMs will be able to easily incorporate the latest security technologies into their products. So to enable advanced security features and improve security in industrial applications, AMD is integrating industry standard hardware accelerators into low-power processing solutions. AMD solutions deliver excellent graphics performance at a wide range of price and power points, enabling OEMs to deliver software-compatible solutions from the very low-end, small form-factor mobile HMIs into high-performance, large-format multi-screen HMIs. This helps reduce software development time and cost compared to using different architectures at the low-end and mid-range or high-end. So for OEMs looking to improve usability of their operator panel solutions through compatible, immersive, and interactive user experience across their operator panel product lines, the excellent graphics performance of the AMD SoC and APU products enables compatible, highly integrated, low-power, and high-performance solutions to be developed. The increase in automation has resulted in industrial systems that are safer for workers to operate. Low-power and high-performance AMD solutions that can operate reliably in industrial environments are helping to deliver more capabilities deeper into the factory floor. When paired with safety-certified software solutions, they can help to enable the safe operation of industrial control systems. Virtualization is enabling separate isolated operating systems that may have operated on separate processing platforms in the past to be run on a single platform. AMD's APUs and SoCs offer virtualization support in hardware to deliver efficiency and excellent performance for this developing architecture to enable highly integrated systems. To support scalability, AMD Embedded Solutions offer footprint-compatible scalability within product families and software and feature compatibility across families. They are available at several different price, power, and performance points to enable a single platform to serve multiple product requirements. And the software and feature compatibility across product lines enables software solutions to be easily scalable across different product categories. To help improve reliability, AMD Embedded Solutions offer low-power processing solutions with ECC memory and extended temperature support, and support for features like virtualization and remote management. Each of these features can help to increase system reliability and reduce factory downtime. Those are the 9 trends in industrial control and automation that I wanted to talk to you about today, and how AMD is delivering solutions to meet their needs. For more information on AMD Embedded Solutions, or to view one of our other webinars, please visit www.amd.com/industrial. Thank you.